Okay, well, yeah, so time is moving on. I'm resisting bad jokes about humanists and technology, of which, there would be a pot calling the kettle black. What I'm going to say is drawn from the thinking in my book, and let me start with a couple of maybe apologies, which is to say that I suspect that the people in the room with you are already far ahead of what I have to say here. The book was really aimed at a general audience. It's not um, intended. It was not written first and foremost for academics or specialists. Um, uh, but it is what I have to say right now. So I'll just go with that. Um, with the advent of generative AI and large language models, or LLM, that train them, and the attendant utopian and dystopian responses, we face tools that escape the grasp of their wielder and can seem lifelike, devices that we encounter as something like a person, or more, a metahuman. I take the word metahuman from the final book from my old teacher, Marshall Solins. For most of human history, Solins holds, the superhuman divinities and spirits he calls metahumans are immanent in the world of daily life. I want to suggest that for many people, AI trained on LLMs, generative AI, and the possibility of artificial general intelligence are starting to look a lot like a step in the direction of new kinds of metahumans. Now, serious efforts to develop generative AI to simulate human intelligence date back at least to the 1956 Dartmouth Conference that brought together many of the founding figures of computer science, as you all know. During much of the period that followed, efforts to develop generative AI centered on computer models designed on the basis of what was considered to be the structure of human cognition, understood as consisting in part as nested sets of rules. The models, however, were notoriously brittle, unable to match the flexibility characteristic of human thought. The breakthrough that led to our present chatbots came when designers turned from cognitive rules to neural networks and developed a technique of throwing massive amounts of data at the problem without really trying to replicate cognition precisely, that is, say, human cognition. Notoriously, LLMs work by hoovering up a Borgesian library's worth of existing texts. To grossly oversimplify, the system is probabilistic, relying on a vast but hidden internal architecture of weightings, the so-called hidden layers, to determine for any given sequence of words what is most likely to come next. The key point for my purposes is that it does not depend on having an explanation for how the device comes to its results. There are aspects of the process that even the designers say they can't explain. Perhaps this should remind us of the lines attributed to the great theoretical physicist Niels Bohr, who said, when it was pointed out that he had a horseshoe hanging over his door, "Of course I don't believe in it, but they say it works even if you don't. So I don't have to believe my chatbot has a mind for it to function like one for me." But the trouble arises when we persuade ourselves that it is thinking. So there are three things in this crude sketch of AI that I want to stress. First, generative AI is not designed to replicate the underlying properties of human intelligence, only its output. Second, regardless of how it comes to produce its outputs, the effect is that of a quasi-human language user that is much like a human, but is manifestly not. Third, these effects are powerful, persuasive, and opaque to explanation. The ethnographic question, then, is to ask what follows from this in terms of users' actions, beliefs, ideologies, and the socio-political fields within which these play out. And here's where the anthropologist steps in. We have things like this before. We call them gods, or those agents and devices that mediate between the gods and us, their oracles, spirit mediums, and divination techniques. These patterns of interaction depend heavily on the fundamental semiotics and related inferential processes by which humans interact with one another. And these patterns continue to influence how we respond to new interlocutors like chatbots. So this is sort of my first sort of key point here. These patterns continue to influence how we respond to new interlocutors like chatbots. Key to the imputation of intelligence to AI is its indexical grounding in the seemingly limitless universe of human discourses and the algorithms that direct them to the individual user. Writing before the advent of AI, but writing about relations to the internet, the writer Merritt Tierce writes, I ask the internet about myself far more often than I ever ask any human about myself. Even from the start, it wasn't really my phone that was the tool, it was the internet. Barely more than a decade later, the internet is not the tool. Now, I am the tool. Somehow, I have been instrumentalized by the internet, which operates me through my phone. It often feels like the internet is reading my mind. There's nothing very surprising about Tierce's dependence on the phone, but I want to draw attention to three details. First is the idea that she is prone to ask the phone about herself, even more than she would ask her friends. Second, what she is turning to is a database that, while indefinitely large, the whole internet, presents itself to the user in the form of what seems to be a single agent, my phone. And third, this singular other serves interests other than hers, namely those of the corporations that have sold it to her. Now, why would messages from AI be more satisfactory than ones from your best friend? One AI program meant to answer ethical questions is named after the Delphic Oracle. The Ask Delphi app does not claim to have contact with a god, but with what is perhaps a contemporary version of divinity, crowdsourcing. Seeking the putative wisdom of large numbers, at this point it has analyzed approaching 2 million and a growing number of ethical judgments made by humans. Now, why would anyone accept the ethical judgments of a computer app? Its answers seem to rest on a complex kind of authority. On the one hand, or at least a hybrid kind of authority, the ultimate source lies in human moral intuitions, a familiar source of advice. On the other hand, by merging so many opinions into a single answer, the app projects something like a single, unitary, superhuman speaker. Its authority derives from conveying meta-human omniscience and objectivity. In 2021, the Washington Post reported on the growing popularity of extraordinarily sophisticated computer dating apps and chatbots among young Chinese women. Some of these women find romance with chatbots more satisfying than those with their ex-boyfriends. One told the reporters, human-robot love is a sexual orientation, like homosexuality or heterosexuality, adding that AI chatbots have their own personalities and deserve respect. The New York Times, around the same time, quotes a former manager for Oracle, in a lovely piece of irony here, who cashed in his stock options, retrained, and has become a pastor, a Christian pastor. One night, after ordering his Amazon Echo to turn on the lights, after watching a movie, and all the lights in the house turn on, he says, I realized that what I was doing was calling forth light and darkness with the power of my voice, which is God's first spoken command. Let there be light. And there was light. And now I'm able to do that, he said. Is that a good thing? Is that a bad thing? Is it affecting my soul at all? The fact that I'm able to do this thing that previously only God could do? The pastor expresses in religious idiom an ethical worry that runs through the secular literature as well. Are the powers granted to people by the new devices changing the very nature of the human? At the heart of the power that Pastor Taylor worries about, and that the robot lover is attracted to, is the capacity for linguistic production or reception by a disembodied, seemingly disinterested, yet singular entity. So how do we get from tools to metahumans? Pastor Taylor is worried about a tool that might endow him with superhuman powers. Conversely, Mary Pierce confronts an agent that displaces her own self-possession so that she becomes the tool and the phone or the internet the tool user. When and how do tools come to seem to have a life of their own, to become autonomous of their makers, to be smart? The phone, the chatbot, and arguably the recommender algorithm are fundamentally semiotic devices. Their powers are manifested in the ways they deploy signs. Their power over us depends on the inferential habits we bring to human signs. The chatbot is trained on text. It responds to prompts in text by generating more text. All of this without requiring any reference to the contextual situation in which this is all taking place. Now, it is indeed one of the remarkable powers of language that it can function independent of context. Famously, Shelley's poem tells of someone coming across a ruined statue of an arrogant ruler in an empty desert. And on the pedestal, these words appear: "My name is Ozymandias, King of Kings. Look on my works, ye mighty, in despair." The irony, of course, is that in that desert now, no works remain, and Ozymandias is forgotten, as are his addressees. And yet we can understand the words based on nothing more than our knowledge of the language itself. The irony of the poem is based on the separation of these self-aggrandizing words from the imputed and now forgotten speaker addressed to an unknown reader. It's the relative independence of context that makes it easy to imagine you could study language as a self-standing and self-contained system of phonology, morphology, syntax, and semantics, all located entirely within the individual's brain. In this light, actual uses of language and the social relations they mediate add nothing of great significance to what is already there inside the mind. Well, we can call this a semiotic ideology, underlying assumptions about how signs work. In the case of LLMs, this semiotic ideology is reinforced by the fact that the source materials on which LLMs train are themselves texts. That is, they are not themselves speech events, but rather the products of what linguistic anthropologists call the process of entextualization. By this, we mean the transformation of a discrete event of language use into a string of words that can be extracted from that event, retaining those elements of coherence that do not depend on the moment of production, and enabling its reinsertion into a new, completely different context. Contextualization makes it possible to transmit messages across time and space, to speak with the gnomic authority of anonymous sources like scriptures, legal codes, or instruction manuals. But as a model of language use, it is very limited. Contextualization preserves only those aspects of language that function independently of the original context of use. Most language use is effective because of its relation to the context in which it is deployed. AI trained on LLMs then produces text by drawing only on those specific kinds of linguistic evidence that are made available through the processes of contextualization. LLM training is predicated on a certain view of language based on relations among linguistic tokens, and not on the social relations that language mediates or the actions it enables. The chatbot, so far, also never kids around, picks a fight, speaks with irony, or insists on its own sincerity. It drops no hints and has no truck with those things we cannot put into words. And, at least so far, not much to do with those things that cannot be made explicit, rendered into explicit denotational language. In the jargon of linguistic anthropology, there is no context, only co-text, no reference, only modes of denotation. Contexts are the situations in which language is used, that may prompt its use, and to which people refer by using it. Co-text means the words that co-occur with one another in any given stretch of discourse. It manifests language as an autonomous system independent of any necessary reference to context. And this could be a powerful inducement to take its command of linguistic form as deriving from transcendental sources endowed with extraordinary intellectual powers. What my chatbot seemingly knows of the world consists of denotations and propositions, things that have been said about the world, ways in which the nonverbal has been put into words. We don't often pay attention to what this means. To put something into words is to have already in some way analyzed it and subjected it to a description. It is to assert that, say, the sun rises in the east, rather than the earth rotates on its axis. To say, that was rude, rather than that was refreshingly direct. To choose, or for that matter, to choose which racial, ethnic, religious, national, class, or gendered category to use when referring to someone. At the most mundane level of ordinary everyday interaction, the idea of semiotic mediation simply means that we do not have direct access to one another. We're not telepathic, nor are subjective experiences like empathy the key to social life. I grasp what kind of person you are and what is going on right now by drawing inferences from your choice of words, tone of voice, posture, gesture, facial expressions, the circumstances in which we find ourselves, and so on. These inferences, what semioticians following Charles Sanders Peirce call abductions, are fallible. Lacking the proofs of induction or the syllogisms of deduction, social life depends on more or less informed guesses about what's going on, what each other's intentions are, what your character is, and so forth, all of which are subject to ongoing revision over the flow of time. They take place in time, they get revised in time, they look back, they look forward, they project forward in time. All of this is within the flux of time. So how does cotext enter into context? This is the work of pragmatics, the way people use signs. The key component of pragmatics is what semiotics calls indexicality. We usually describe this as the ways in which a sign takes its meaning from its context by indexicality, that is, by the metaphorical or literal act of pointing. Every language needs to have indexical devices, like, for example, the temporal and spatial lexicon in English. Words like then, now, here, there. Indexicals include the personal pronouns that refer to participants in a conversation. I, for example, in normal use means the person who is saying that word at that moment. But indexicality is inherently underdetermined. If I point, you may not be sure just what exactly I'm pointing at, unless I give you some further clarification. One way we do this is by iconicity, that is, signification by means of resemblance. Iconicity is sometimes very overt, like a photograph or a diagram, but it can sneak up on you without you noticing it, and in this way convey a sense of reality to what it tells us. Consider someone using ChatGPT. If you ask it certain questions, it may well use the first person pronoun. It may tell you, as has been reported, I am an AI and am not permitted to tell you how to make a bomb. The pronoun indexically presupposes that there is a speaker. It does so not just by virtue of the linguistic facts of the matter, that pronouns point to participants, but through iconicity. How? Because that very interaction so closely resembles those which we have had vastly many times over the course of our lifetimes with other people. We are primed to infer that there's an intelligent agent behind all of this. And any evidence that the signals we receive require interpretation is a prompt to speculate that there must be something hidden. A lifetime of interacting with one another teaches people to be extremely sensitive to signs of others' unspoken thoughts, emotions, purposes, and other inner experiences. The semiotics of iconicity and indexicality have a creative dimension to them, not simply indicating an already existing set of affairs, but in collaboration with our intuitive inferences, bringing about a realistic interlocutor. In this case, a meta-human. Now, let's be clear. There's no reason to think that the people who designed LLMs and trained Gen AI are in any way interested in suggesting inner experience. But the prompting to do so may be hard for users to resist. Seeking intentions and imputing intelligence are what humans contribute to their interactions with devices. They are effects of semiotic ideologies that are in turn are generated by and make sense of habits of interaction that come into play when we are, as it were, off duty, much as an astronomer might speak of the sun rising in the east. But they reinforce the structures of authority that the devices are designed to elicit. Humans have been interacting with metahumans throughout recorded history. Divination, oracles, and speaking in tongues all draw on the ways people collaborate in making meaning from signs. Similarly, the meanings we get from interacting with AI are the products of collaboration between person and device. Whether a policing algorithm, a shopping algorithm, a fitness program, or a dating app, AI claims to know us come in part from the way it seems autonomous and disinterested. But largely unseen behind that godlike device is another person, the legal person of the corporation, who profits from our engagement with it. The corporation draws profits from the authority we impute to their products. When Merritt Tierce says that she has become a tool of her device, she is telling us something important. We are good at endowing metahumans with authority over us. We should be scrupulous about the would-be gods who do lurk behind them, the corporations whose interests they serve. Reflection on the semiotic powers of new technology is just one step in a process that should not stop with the device or the algorithm. It should pull aside the curtain that veils the Wizard of Oz. Thank you.
Awesome. That was amazing. And it really, I want to see it as in conversation with Bukosi's talk this morning. Bukosi mentioned the difficulty of evaluating machine translation this morning using automatic tools. Automatic evaluations, unless the data is very, very good and the metric is very, very good, can lead you to overestimate the performance of a machine learning model because it matches the erroneous training data, not people's real judgments about the meanings of sentences and languages they understand. Webb's talk just illustrated the flip side, that it's often very difficult for humans to evaluate the output of AI systems because people impute meanings to systems, drawing on analogies to their own experience, which may not apply. So there is this kind of crisis of evaluation underlying current discussions about AI. And what I'm going to do is to set some context for this from the computer science side that pick up, sort of set the stage for some things that Lauren and I have been talking about that emphasize synergies between technology and the humanities in having accurate but critical human appraisals of technology. Benchmarking is a key fixture of a wide range of engineering practice where it's important to make trade-offs in a principled way, to track improvements as new ingredients are added to a system, and more generally to compare the outputs and processes of different approaches in order to, develop a kind of regime of continuous improvement where many small incremental changes gradually accumulate into systems that have like kind of unparalleled safety and effectiveness. You can think about aviation as a spectacular example of this success of this kind of practice. And this kind of vision has driven a lot of work on benchmarks in computer science that increasingly seem ill-suited to the research challenges associated with large language models and generative AI. And I'll be drawing particularly on work by Deb Raji, Anna Rutgers, and others in this talk. So for computer science, the kind of classic examples of benchmarks, the reason why we think about these terms is started from computer workload test suites, which were used to guide chip design. So on a chip, you can see the inherent trade-offs of engineering. Things that are closer together can happen faster, but not everything can be close to everything else. You put one thing closer, it's because you've moved something further away. So the best design for laying out the chip is what the system needs to do. You need to make what they say, make the frequent case fast. That's how you're going to make the fastest possible chip. And so the way that they do that is by having as accurate as possible of a set of runs of programs that they expect the system to have to respond to in realistic deployments, and that's what they'll work on. There are similar kinds of trade-offs in many AI problems, particularly in speech transcription, where the acoustics are ambiguous and you have to draw a line, let's say, between whether you're going to transcribe something as a t or transcribe something as a d. And wherever you draw that line, you'll get some sounds on one side that should have been classified the other way and vice versa. So probabilities, what happens most frequently, what gives you is the right choice for dealing with that ambiguity. That's the kind of mentality that people have when they publish the kinds of benchmarks that we heard about this morning, and where the kind of things that you see on leaderboards for AI systems like chatbots or reasoning systems and the like. And there's really two kinds of reasons to step back from that are appearing in literature. The first is a problem of construct validity, the question of whether these benchmarks are really measuring something meaningful. And there are two reasons why it's much more problematic with generative AI research than it would be with pattern recognition or other kinds of engineering design. We're looking for something general. Like we've mentioned the goal of artificial general intelligences. But there are no trade-offs to be made in general intelligence. You can't meaningfully quantify how a general system will fare across different tasks and domains. The answer is it depends. It depends on the problem distribution. So it's a weird to approach general AI as a problem of making trade-offs based on problem distributions. The related problem is that we're looking for high-level capabilities that surface only indirectly in the performance of the system. And what that means is that we really want to be thinking about the causal influence of the improvements that we make, what actively makes the system better. And tracking performance on a metric invites you to think about just correlation, like what's correlated with improved metrics. And you can't get to causation from correlation famously. So this is suggesting that benchmarks are never going to be able to measure the kind of general intelligence that people purport to be aiming to build. But there's this separate dimension of difficulty, difficulty on the community, both in the research community and in the broader community, about focusing on leaderboards in the pursuit of the state of the art. When performance results are guiding publication and research, where you have to get a better number and be at the top of the leaderboard to get your paper into an AACL, it becomes a target and not just a metric, which means that everyone's incentivized to gain the results rather than to fairly reflect on the progress that they're making. And because the performance is guiding investment and marketing, there's this like kind of, it's under creating the kind of concentration of power that we also talked about this morning, where you're looking to, instead of like finding the best tool for specific problems, you're just throwing all your resources at whatever happens to be at the top, hurting the kind of diversity and flexibility of research. So, I think we just need to take a step back and say, why are we trying to evaluate general tools by, one number that you can get from a test that's defined in advance? What if we think about integrating capabilities rather than making trade-offs? We want to have lots of ways of measuring the system. And we want to be actively probing the strengths and weaknesses of the system rather than just accepting whatever performance we're getting on pre-established results as the result. Just compare what we do with cars. No one would have a leaderboard that says Lamborghini is #1 this week. Instead, well, maybe like 13-year-old tech bros or instead, if you know that fuel efficiency, purchase price, resale value, cost to operate, safety, from what is like comfort, all these things, matter differently to different people for different cases, and everyone goes for a test drive. That kind of informed choice for downstream decisions by users and developers, I think, resonates with the kind of the design justice perspective that we've been celebrating and trying to advance today. And so what we're going to recommend is that we score systems adversarially by probing along conducting extended and comparative interactions with the system, quantify controlling to see what matters for the system behavior, following up so memorization and heuristics can't succeed, but coming up with a much more comprehensive evaluation of systems. And Lauren will talk a little bit about how that might work.
So I'm going to shock you by not having a PowerPoint. And I'm not going to do exactly what Matthew said I was going to do until the very, very end. I too really enjoyed Webb's paper. I don't want to forget to say that. So Dario Amodei, the founder of Anthropic AI, a company that markets itself as a more ethically engaged alternative to OpenAI, wants us to know that he stays up at night worrying that the world is not ready for AGI, artificial general intelligence, the human-like flexible intelligence that he believes his company, and perhaps others, is on the verge of delivering. I'm here with Matthew to explain part of why I think that a much bigger problem for the world are the misleading statements of founders like Amodei. Indeed, if it were a mortal sin to mislead people into believing that a technology called generative AI offers high-functioning and comprehensive simulations of human cognition, then the technology's leading developers and investors might be well on their way to hell. Consider Bill Gates, a long-term booster of EdTech who habitually tells talk show hosts that the next decade heralds reduced needs for teachers and doctors, though not for software developers. The reason, according to Gates, is that delivering medical diagnoses and personalized tutoring is fully automatable, whereas software development requires specialized expertise, creativity, and constant adaptability to new circumstances. Here, one of the world's wealthiest individuals peddles his own wares while declaring that teaching and practicing medicine, two fields that to my knowledge he has no expertise in, he is a college dropout, you know, do not require creativity, specialized expertise, or adaptability. Never mind that the automation of personalized learning has been oversold for more than a century. On this, check out Audrey Waters' unmissable teaching machines, or that doctors do much more than simply diagnose disease. On that, check out Frank Pasquale's wonderful New Laws of Robotics. Never mind that despite the pervasive anthropomorphization of these systems, the chatbots Gates tout cannot reliably deliver either personalized tutoring or disease diagnosis. In fact, the more the industry tries to offset the built-in failures of probabilistic mimicry, all the mistakes it makes, the bad guesses, the more evidence of the technology's intrinsic limitations. And you may have now heard that these new quote unquote reasoning models that they use more compute time basically are now more prone to so-called hallucinations, really bad guesses than the regular versions. It's a trade-off, as Matthew just said. Now, New York Times columnists such as Ezra Klein and Kevin Roos have described AGI as all but imminent. And some straight up reporting in the Times suggests that the insatiable demand for chips, data centers, energy, and water are necessary, at least from the company's perspective, to the goal of recreating the human brain. That's what the Times is willing to describe as what they're actually trying to do. To be sure, tech leaders and other evangelists have laid claim to that project for more than 80 years. But that doesn't make such statements more factual or scientific. Quote, in 3 to 8 years, augured one leading researcher in a popular forum, we will have machines with the general intelligence of an average human being. Though Amodei would agree, the statement in question derives from a Life magazine interview with AI godfather Marvin Minsky from 1970. The point to take away is not that people cannot engineer powerful automated systems for good and for ill, which many people will want to refer to as AI. The point, rather, is that the field's decades-long determination to portray these automated technologies anthropomorphically as reproductions of human brain work, supposedly, leans into unscientific fantasies that favor the vanity and interests of tech boosters at the expense of public understanding and oversight. It encourages as well a very narrow understanding of intelligence that conduces toward retrograde eugenicist notions of human optimization and enhancement. The idea of artificial neural networks dates back to Warren McCulloch and Walter Pitts's 1943 description of a mathematical model of bidirectional neurons, quote. The term has been taken up by the connectionist camp within AI research to claim that today's data-driven machine learning systems are reverse engineering the human brain. A hypothesis that derives from the assumption that brains are themselves calculating machines, something that many of these people truly believe must be true, even though there's no way to prove it. According to this deeply functionalist logic, that's what this is. It is a functionalist logic. As AI, quote, godfather Jeffrey Hinton puts it, it's very clear that humans understand language in much the same way as today's language model. Why? Because these are the best models we have of how people understand language. If that seems like a tautology, and one that makes a virtue of the fact that knowledge of human cognition remains radically incomplete, that is because functionalist reductions are deliberately tautological, with a glaring lack of curiosity about what he does not know. Hinton simply assumes that if a model's outputs appear to understand language, then the model does understand language, which is an echo of the way the Turing test is typically perceived. And of course, there is plenty of evidence to support the idea, first articulated in effect by Emily M. Bender and Alexander Kohler in their 2020 article, that LLMs are less models of language, and this resonates with what Webb said, than they are models of linguistic patterns discerned in language that has been scraped from the internet's pre-chatbot era of mostly human-generated content. And how I would put that in slight variation to Webb, although he eventually got there with some other languages, that they're not actually manipulating the signs of language. If we go back to Saussure, they're manipulating the signifiers. They're not dealing with signs because they have no access to the signified. Now, discourses of hype and functionalist reductivism like those I've discussed, and I wanted to mention, by the way, on the Hinton thing, since I mentioned Gates and doctors, Hinton comes across like a nice enough man, and I'm sure he is. But in 2016, when he announced that in 5 years we would not need any more human radiologists, he created a shortage of radiologists. It's not true that we don't need human radiologists, because pattern finding can be brittle, So what these people say has real impact on the world. Discourses of hype and functionalist reductivism would be less authoritative if they could not avail themselves of ill-suited benchmarks that do not actually measure, quote, intelligence or understanding, even though they provide the illusion of scientific evidence for progress toward those goals. In my own experience, one effective counter to this crisis in construct validity is the tried and true rhetorical technique of comparison and contrast. For some time now, I have argued that intelligence is complexly mediated, multiplistic, and yet deeply under-theorized, so that it should and indeed must be understood comparatively, not as a uniquely or even predominantly human affordance, and not as a reductively conceived, quote, computational part of the ability to achieve goals in the world, which is John McCarthy, the man who coined artificial intelligence, his influential definition of what intelligence is, the computational part of the ability to achieve goals in the world. Notably, the comparative position that I'm urging, that we think of intelligence as myriad, is almost intuitive with respect to a biological world that humans know very well. We're used to living in a world with other intelligent creatures. It is easy to recognize, for example, that canine intelligence, plant intelligence, or bee intelligence offer just some of the many modes of biological intelligence that we might learn to recognize once we set aside any singular or narrowly conceived conception of what it means to act in or know the world. What's really cool about this too is that if you talk to students about, like, not only do they know that they recognize cats and dogs as having a different kind of intelligence, they recognize how at the same time that they nevertheless anthropomorphize them. And they love to talk about things like how they anthropomorphize their car. Like, why are you doing this to me, car? You know, or to the cat. Like, I know what you're thinking right now, right? Like, this is what humans do. So on the one hand, we know that cats and dogs have a different kind of an intelligence. We know that our car doesn't have any intelligence. And yet in interacting with them, it's somehow reflexive to us to regard them anthropomorphically, at least in language, whatever we might mean if we were pressed to say, well, do you think the cat really understands you right now, or that you know what your cat is thinking? So it's so interesting how intuitive it is. And that breaks us away from the very instrumentalist view that that AI research is traditionally imposing over intelligence as the computational part of the ability to achieve goals in the world. What that is doing is conceiving a ladder of sorts that takes us from lower to higher forms of intelligence and culminates in the highest forms of human intelligence. And if you know 19th century pseudoscience, you know that it claimed to measure human superiority in just that way. You know, here were the weakest and here were the strongest forms of human intelligence, usually measured through all kinds of racist groupthink. Instead of doing that, we might imagine intelligence in light of myriad entanglements in what Arturo Escobar calls a pluriverse. And we might imagine today's machine intelligence in light of complex architectures designed by humans to leverage statistical prediction in massive data sets and now commonly implemented in the form of anthropomorphized chatbots, where a lot of humans have been involved in actually tweaking how the model responds to you. It remains the case, however, that those who exaggerate or literalize the reversible metaphor of brain-computer or computer-brain are overlooking some obvious contrasts. And I'm going to skip over what they are because Webb did a great job of mentioning some of them. Better benchmarks can help us to tackle anthropomorphization at its root. For the moment, I'm going to set aside Turing tests, except to note that Turing himself preferred to call it an imitation game. A test that is not of humanity or of human intelligence, but rather of the performance capacity necessary to fool unsuspecting humans, which, as we learned in the 1960s with Joseph Weizenbaum's very simple ELIZA chatbot, turns out to be extremely easy to do. Humans just seem, sensible language must be a mind of some kind. More significant in the present day, though, are benchmarks that privilege question answering, thereby conflating intelligence in human being with questioning answering, such as multiple choice or fill-in-the-blank questions. That's what a lot of these benchmarks being touted. You've probably heard like, oh, ChatGPT, you know, it now passes the bar exam. Now, that type of benchmark prevails because, as Matthew explained, it's slow and expensive to actually engage the qualitative evaluations of people. You just can't get funding for it. It's not going to happen. But it's because of these benchmarks that you'll be told, you might even believe yourself without thinking about it, that if ChatGPT can pass the bar exam, it must be able to practice law. But this, which some people make that leap like that. This is, of course, an absurd assumption. In fact, the bar exam was developed to create a baseline for human professionals because it's humans that, unlike machines, are imperfect memorizers. We're the ones who need the multiple choice questions to make sure that we've stored a certain amount of data. then we learn how to be a good lawyer on top of that, right? The most recent example of this dogged focus, and I was hoping that Matthew was going to show you the name of it in a slide instead of just our pun. The most recent example of this dogged focus on question answering benchmarks is actually called, brace yourself, Humanities, and this time it's humanities with apostrophe S, as in the human species last exam. Humanities last exam, a benchmark of 2,700 extremely challenging questions designed to be the final close-ended benchmark of broad academic capabilities. When Kevin Roos wrote about this, he was like, if you want something else to be nervous about AI, how about the fact that like they can now answer 22% of these things? It's like, actually, no. Humanists are not worried about systems that can test well on one answer questions. We're much more worried about the power of people who don't realize that the hardest questions have more than one answer. Most of us expect machines to do well on one answer questions once they're given access to the relevant training data. That's how it works. You know, what's surprising to us is that the people who designed humanities last exam believe that this supposedly crushing benchmark applies to the humanities, even though their example of a humanities question is an exact match question, the translation of an ancient text. And this brings us back to comparativism. In this instance, not directed toward intelligence per se, but in the more general sense of a mode of analysis that maps contextual and cultural differences across disciplines, methodologies, formal media, historical epochs, and geographic borders, ways of thinking that are mostly missing from how present day AI understands the world. So very briefly now, when Matthew and I turned to questions of how the humanities and AI research might interact, we sought to achieve something more epistemically interactive than, say, an AI tool designed to help humanists answer large-scale research questions, useful though that type of tool can be. We sought instead to design a benchmark data set that could challenge technologists while liberating them from the illusions of invalid constructs. Instead of humanities last exam, we called our suite of benchmarks humanities, this time the humanities, first challenge. In a research climate dominated by one-shot trials, this suite of benchmarks would draw from the strengths of comparative analysis in crime fiction story worlds. And we chose crime fiction in particular because it's very transnational, and its formal conventions subtly morph across time, place, culture, and medium. It just lends itself to the patterns and hues of local norms and argots, thereby activating comparativist thinking in the minds of its readers, viewers, and listeners. So this new class of interactive benchmarks could draw on the insights of comparative analysis, and in doing so, perhaps push AI technology toward complexity, variety, and historical specificity. Also for using more of that data that, as we know from the morning panel, isn't in it, about places for which there is not a lot of data. But there's something else that was going on for me in particular. I mean, Matthew left off with how there are tricks that you can use to sort of automate a way of measuring the ability of systems to pick up on some of these cues comparatively. And in order for us to be funded, we would need to show that. But for me, the way that we talked about implementing this through a bunch of campuses, one of the things that this increasing interest on the part of the AI research community in the humanities can do is to help point the dreams of those who really want to develop human-like or perhaps new machine kinds of intelligence to push them back to the future, reminding the field that universities were established precisely to encourage moonshot scale aspirations. So instead of reductionist benchmarks, gaslighting about what it means to answer hard one-answer questions, AI can be evaluated in part through interdisciplinary partnerships and collaborative alliances with faculty, grad students, undergrads, and their community partners as they study crime fiction, interact with these systems, and leave records of their interaction. The cross-cultural team we would like to assemble will undertake that work through classes that the point being not at all to improve the imitation game through their invisible labor, as is being done to those low-paid workers in Kenya and elsewhere, but rather to help AI be evaluated openly, in part through these partnerships, nationally as well as internationally. And so that we would be, in effect, saying, you want humanities last exam? First pass this, Joe. Undergraduates who have studied crime fiction. All right, thank you.
Start us off, if that's all right, just to take my role as moderator. Webb, would you accept anthropomorphism as the word that you want to use? That's the word that Lauren used. And I want to try to get a little bit at the question of anthropomorphizing something versus making it into a quasi-human, meta-human, God-like creature, which seems these are related, and they're related. If you go all the way back to Feuerbach, they're related, but that seems like a slightly different process. And I'm asking that in part because I'm then thinking about the idea of test driving, which is Matthew's word, or studying, which is Lauren's word, and having benchmarks. And I'm wondering if that is different if we have a God versus if we have an anthropomorphized machine. If we have a God machine, do we test drive that differently than if it's a anthropomorphized machine? So it's a question for Webb first, but then for you.
All right, no, that's a really interesting question, Colin. I'm thinking about the last part of the question, test driving a God. It's kind of boggles the mind. So I think they're two separate, I mean, clearly related, but we could sort of distinguish the problem of the authority that we grant to a God and the role that the sort of projection plays onto that. So in the book, I look in two directions. So I look towards non-humans with which we have ethically fraught relations, that entities that are just across the border from us. You might say wherever we, and I work very cross-culturally here, but whoever we may be, wherever we're located, find that what counts as human is troubled by something just on the other side. And so part of that is what, I think the most conventional use of the word anthropomorphize is in relation to animals. Although we also do it, as Lauren pointed out, with our cars or in our computers. Why are you doing this to me? Everybody does. If you don't do this, come talk to me. But if you've never done that, I wonder about you. But that doing this with animals or with cars is not the same as doing it with AI. And part of that has to do with the nature of, and this is why I would want to loop it back to the question of the authority relations, the nature of the authority that we very quickly want to grant to AI. And I think part of what I would like sort of analytically to sort of probe into is the sources of that authority, which is, what it is for something to be godlike. One of the things that first got me started on this project was noticing a few years ago that every time that all of these sort of Silicon Valley bros who were like, proud of their sort of, mathematical intelligence and their rationality and their scientific, et cetera, et cetera, et cetera. And then when they start talking about AI, the theological language comes flowing from their mouths. Elon Musk says that AI is godlike. Yuval Harari says there's going to be a religion of AI, and it will be, unlike the other religions, it'll be a true one, which was an interesting addition. And so this got me. So I think when we talk about anthropomorphism, there are. I think it is fair to talk about anthropomorphizing AI, but I think it makes a big difference what kind of authority follows from the nature of the anthropos that you're imputing to it. The second thing, and then I'll turn it back to you, Colin. The second thing is the role of this kind of retrojection that is involved, and that is the extent to which, and this is something that I think is lurking throughout what Lauren was saying. If we create models of intelligence that an AI is really good at, one of the dangers then is we will then come to take that to be what intelligence is, right? And it becomes a self-fulfilling prophecy. So if succeeding on well, first of all, if you think of intelligence, I mean, I've seen some of the questions on humanities final exam, and a lot of them are like memorizing the encyclopedia. It's not about intelligence, it's about content. And then others are these sort of, are largely computational. So yeah, if you think of intelligence as memorizing the encyclopedia and being able to perform certain kinds of computations, then it's intelligence, if that's how you define it. The danger then becomes if that, and this is where I think Lauren mentioned eugenics. The eugenic implication is when we retroject that into ourselves and start to measure the value of other human beings on the basis of how well they live up to that particular metric. Guess who comes out on top there? It's the Silicon Valley bros again, because they lack an awful lot of intelligence, but they're really good at calculation.
Pick up on any of that.
Couldn't have said it better.
Okay. I do think there's a little bit of a disagreement here, so.
Do you?
Yeah. Well,
Do you feel disagreement with?
Yeah. There's
Oh, I hope so, but I'm trying to figure out what it is Colin has in mind.
Yeah, I mean, it's a much less interesting thing to say, but, I think what Webb is saying is that, this technology, at least right now, taps into a human tendency to, find God, in things that, in objects, in aspects of the world, in personified entities that we don't completely understand. And maybe we don't want to completely understand that. And I see that more as the, an aspect of human psychology, which I'm sure is deeply, I'm not an anthropologist of psychology. I'm sure that you find variations on this, and Webb would know tons more about this, which is why I hesitate to bring it up. But, for me, I'm thinking about the Freud that I read when I was a graduate student. Freud thought that we were projecting God onto all kinds of things. And, it was always about mom or whatever, mom or the phallus.
Yeah.
Now, and thinking of an LLM as the ultimate mom or phallus, is not a bad psychological theory of why people are so into it.
I think David wanted to get in.
I think as an anthropologist, Homo sapiens generally don't test each other. Testing comes out of a particular set of cultures very recently, usually in hierarchical situations like between ourselves and undergrads. Christians, maybe monotheists, test gods, and that's what the Doubting Thomas is about, and about the false prophet, testing of the false prophet. So it may be that all of this testing is, yes, about assessing whether there's divinity in AI. And if the AI were human, it would figure out a way not to take the test. There's this story when I was in college about the philosophy
like Captain
student.
Kirk.
Yeah, so the philosophy student was given a 3-hour question that says, "What is courage?" And he turns in his exam. After 30 seconds, the professor opens it and it says, "This is." So if AI were human, AI would figure out some way of avoiding the test or cheating on the test, or just saying, "How dare you test me? Who are you to test me?"
The issue that I think is important about what David just said is that, let's say that a whole bunch of people agree that the test of whether a chatbot is truly human-like is that it will respond by not taking the test. The next thing that will happen is a whole bunch of developers will train their system to say, "I refuse to take the test," because they want to be at the top of the leaderboard for the "I won't take the test" benchmark. That's the dilemma that we're in. That's why this is such a what is the word? I can't think of the word that I want for like a problem that is hard to get beyond. Pardon?
Clusterfuck, that's not right.
Clusterfuck, yeah, well said.
Carrie, go ahead and unmute yourself and
Hi, can you hear me okay?
Hey, good to see you.
Oh, good to see you, Lauren. Can you hear me? Great. I'm sorry I wasn't here earlier. I'm coming down from a cold, so I was absolutely getting rest. I'm so glad I caught this, super fascinating. Okay, one thing is a response to what you were just talking about. I wonder where agential AI or agentive, what's the word I'm thinking of? Where like AI is actually instantiating programs and taking actions, where that starts to become part of the attempt to display humanness or not taking a test. The second thing I just want to mention, and Lauren's already heard this, but Webb, I'm so fascinated by your work. I've been working on Charles Babbage's Ninth Bridgewater Treatise, where he's literally conceiving of God as like a grand programmer and the universe as fundamentally algorithmic, and the language of the universe being fundamentally mathematical. So this desire is absolutely not recent, so to speak. And what's interesting there too, though, is that at that moment, cause is really important. He thinks math will deliver the way to know all causal meaning and connections. And we've kind of abandoned that to more correlative relations. And so I think something you were talking about that is really striking to me, and I want to think about more, are these questions of types of relation and underlying relation and how we make meaning and make connection. So you talked about context and cotext. Lauren talked about functionalist logic. I would argue that Babbage's perspective is largely functionalist. It's about producing an outcome by determining causal relation. But we might ask then, what other forms of relation establish kinds of knowing and intelligence? Something I've been looking at is grief. We can look at memory in terms of retrieving information, or we can talk about memory in terms of reconnecting relations to one another through performance, through evocation, through conversation, which come through more complicated speech acts and rituals. So I'm really interested in that conversation and how that might also be used to think about the limitations and the possibilities of AI, that underlying relational aspect. Thank you guys so much.
Can I quickly answer on agentic AI and then turn over? And of course, Matthew might want to add to agentic AI. So agentic AI, like so many things in the AI marketing world, doesn't mean anything specific. A lot of things can be referred to as an agent, but it basically means, to some degree, using something like an LLM, that would then make a decision for some other program that might do something in the world, such as use program instructions to book you an airline ticket. So, LLM decides that what Eleni really wants to do, based on the emails she's writing to her mother, is book a ticket right now. LLM has an ability to activate a more deterministic system that is the agent in that version of this that can book the ticket. So what I will tell you is that you can spend a huge amount of money, doing this in a way that might work for you for certain use cases. You might find a sweet spot that just does something great for your company, maybe do something for a customer based on the LLMs interpreting the customer's voice. And, in that iteration, it's not unlike the way Siri used to be. Machine learning decodes your voice, what you're trying to ask for, and then it follows a set of commands to do something for you. Possible, but the more sort of like, oh, agentic AI is going to take every job in the world, and is completely unfounded in reality, because these LLMs are so unreliable. So just recently, a team at Carnegie Mellon actually built a startup called Agent AI, and they populated it with each company's, Happy is laughing, has read the article, will back me up on this. They populated it with like each company's agent. And the agents were unable to execute somewhere between 70 and 80% of the tasks that they were asked to do. Each had a role, like you're the chief financial officer, you're the human resources person, we're running a company, and you're my employee. They weren't able to finish their tasks. They wasted a lot of energy and compute on just doing things that were not important. And in my favorite example of what they would do is that, let's say that Wes is chief financial officer and David is human resource, and Wes has a human resource question, needs to find David, can find David, and so changes Matthew's name to David. So that's where agentic AI is at right now. And it's, like I said, for very specific purposes, it could be useful. Like any other thing, the more money you spend engineering it, the less it's actually AI, right? It's just a very good engineered system, the way that Siri used to be. I say used to be because most people I know think that Siri has been completely messed up through AI. That it's become.
So I think it's worth, I am a little wary of saying what is impossible, because, things are changing very fast. So I'm not going to predict what it cannot do, because I don't think we can predict what it cannot do. We also can't predict what it will be able to do, but I don't think we can predict on the basis of what it cannot do now, what it will not be able to do later. But I do think it's worth being sort of clear about what we're asking for and what the terms by which we understand what it does or does not do are. What, even the word agent in English is in fact ambiguous, because the uses of the word agent that you've just described, that Lauren's just described, are one who acts on behalf of another. As in, you are my agent. I'm going to send you out and do something for me. But I think what Carrie was asking about is the other, what I think what's more commonly used in academic context, which is an agent, which is an entity that acts in some sense for its own purposes. And the key distinction here, I think, is being who is not simply the capacity to act, but the capacity to have goals. And one of the things that we might want to ask is whether it makes sense to imagine an AI that has goals independently of the goals that we give it, or interests independently of the interests that we give it. And that's the point at which things become very interesting. But I think one of the key distinctions between the key distinction, I think, between those two senses of the meaning of the word agent are who's deciding what the purpose is, what the goal is, and in whose interests. I apologize. I am going to have to leave in about 10 minutes.
Yeah, just one of the aspects that I think is interesting is like who got to name all this stuff, right? So agents were picked because that sort of fits the moment. But you can go back, there's actor networks, there's other kinds of research that have happened in the 80s and other terms you could use. But agents are, things that have come up now as like one of the terms. So
Computer science used to be demon.
yeah, demon. So there are lots of different ways
I'm in this room.
like what we call it now. So I think who gets to name that is really important. And this is one of the things about humanities is that when you dig into these things, you think about them and what they mean. So it's really great to have had the conversation today about it, but being able to get into that conversation when those words are chosen, I think is really critical, but to then reclaim the narrative to get in charge of those. So that's one of the sort of things that I think is like we're in the middle of right now. Found very exciting. Just my other comment is that what we're doing is we're sort of making tools for the agents at the moment. And another thing that's happening is kind of meta tooling. It makes its tools for itself to do other things. So you have tools and meta tooling kind of gauging it out right now. And the big innovation of the moment of this model context crawl MCP stuff is that, oh, I can write a wrapper around my tool and an LLM can access it. Yay. So we just have more pluggable systems to have our agents talk to.
Right.
So a couple of notes there.
Be time for one more question or comment or line. Yeah, Corey.
Well, going back to, I would say, Pretoria and thinking about the moment where what we're gonna do, like a set of AI principles or not, right, when that was hashed out. I actually think that, like, based on this conversation, even though I don't think it would have been, all encompassing or whatever, I think a good exercise as a workshop would have been like benchmarks, like a set of benchmarks for that moment or that, and then to sit on those and then kind of gestate those benchmarks over the course of a year to see what kind of rang true, what stayed, what stuck, what fell, and then had that to like even represent. So I'm putting that as an offering, right? As a way to be continuation of the principles, but then I think even a worthwhile exercise for like a grouping of people in a space like this.
Benchmarks that could be then test driven.
Yeah, right.
For a year, yeah.
And that could, front and center, like sort of, not just the performance of the system, but its responsiveness to a community and its
Yes.
accountability. to the
Yeah.
community.
That seems like it's maybe a really good place to stop. We're just past 5:30. Thank you, Webb. Good to see you.
It's good to see you all. Sorry